Welcome to this comprehensive guide on C-sharp nullable types, designed specifically for beginner developers. In C-sharp, value types like integers, booleans, and dates cannot be assigned a null value by default, meaning they must always hold a specific value. Nullable types address this limitation, allowing value types to explicitly represent the absence of a value, which is crucial for many programming scenarios. They are particularly useful when a value type needs to represent an undefined or unknown state, such as when interacting with databases or handling optional parameters and functions. The syntax for declaring nullable types is straightforward, using either the nullable data type generic structure or the more common shorthand data type operator. For instance, you can declare a nullable integer as int, nullable int equals null, or a nullable boolean as bool, is active equals null. Let's now differentiate between nullable value types and nullable reference types, a key concept in modern C-sharp development. Value types, such as int, bool, or structs, are stored directly in memory and cannot be null unless explicitly declared as nullable. Reference types, like string, object, or class instances, can be null by default, meaning they don't point to any memory location. Introduced in C-sharp 8.0, nullable reference types help prevent null reference exception by allowing developers to specify whether a reference type can be null. You can enable nullable reference types by adding nullable enable/nullable to your docs.proj file. Alternatively, you can use the hashtag nullable enable directive at the beginning of a specific code file to enable it locally. This feature provides compiler warnings for potential null reference exceptions, guiding you to write safer code. Now, let's explore the practical ways to work with nullable types and safely access their values. It's essential to check if a nullable type has a value before accessing it to prevent runtime exceptions. The hasValue property is your primary tool to determine if a nullable variable has been assigned a value. You can access the actual value of a nullable type using its value property, but only after confirming it has value. Accessing value when hasValue is false will throw an invalid operation exception, so always check first. The getValueOrDefault method provides a safer way to retrieve the value, returning a default value if the nullable type is null. The null coalescing operator offers a concise shorthand for providing a default value when a nullable type is null. This operator returns the left-hand operand if it's not null. Otherwise, it returns the right-hand operand. The null conditional operator dot simplifies null checks when accessing properties or calling methods on nullable types. It returns null if the left-hand operand is null, preventing a null reference exception from occurring. Let's dive into practical demonstrations of nullable types within the Visual Studio environment. Declaring nullable variables in Visual Studio is straightforward, using both the nullable t and the shorthand. Here, we declare a nullable integer and a nullable double, demonstrating their initialization with null or a specific value. You can perform operations on nullable types, such as addition, subtraction, and comparison, but with careful consideration for null values. When one of the operands is null, the result of the operation often becomes null itself. To get a meaningful result, you can use the null coalescing operator to provide default values for null operands. Debugging nullable types in Visual Studio allows you to inspect their values and hasValue properties, helping you understand their state. Visual Studio also provides helpful compiler warnings for potential null reference exceptions when working with nullable reference types, guiding you to fix issues proactively. Next, we'll explore how nullable types are applied within the Unity 3D game engine, showcasing their utility in game development. Declaring nullable variables in Unity C# scripts follows the same syntax as in general C# applications. Common use cases in Unity include optional parameters and methods, representing missing or uninitialized values, and handling data from external sources. For example, a game might use a nullable boolean to represent whether an optional power-up is currently active. When dealing with Unity components, nullable types can help manage the potential absence of a component on a game object. The null conditional operator is particularly useful in Unity to safely access components and properties without risking null reference exception. You can then check if the component exists using hasValue and enable it if present. This prevents errors if the subobject or its like component is not found in the scene. Finally, let's summarize best practices and conclude our discussion on C# nullable types. Always use has value or the null coalescing operator to avoid null exceptions when working with nullable value types. Enable nullable reference types in C# 8.0 and above to catch potential null issues at compile time, improving code reliability. Utilize nullable types when interacting with external data sources where values might be missing or undefined. Be cautious when using the null forgiving operator, as it bypasses compiler safety. Only use it when you are absolutely certain a value is not null. In summary, nullable types in C# are powerful tools for handling missing or undefined values, preventing null reference exceptions, and improving code clarity. Mastering them will lead to more robust and maintainable applications, whether you're building general C# programs or developing games in Unity. We encourage you to explore further documentation and experiment with nullable types in your own projects to solidify your understanding. Thank you for watching this training video on C# nullable types.